Hi all, this is section 1.5, the theory of the firm and market structures, and today we're looking at revenue and profits. So first thing we'll do is get our heads around the terminology. Total revenue, nothing new to you, price of the good times the quantity sold. Average revenue is just the revenue per unit sold, so total revenue divided by quantity, and marginal revenue is the change in total revenue over the change in quantity, essentially the additional revenue from selling one more unit. Now, when we examine the revenue of firms, we must realize that there are two types of market. One where the firm is a price taker and has no influence on price, and one where the firm is a large enough player in the market that it can influence the product price. We will discuss market structures in much more depth later on. Okay, we're looking at a firm with no price control. As you can see, the price does not change. It's 10 the whole time. Pause now, draw up this table and calculate total revenue, marginal revenue, and average revenue. Okay, should look like this. If it doesn't, well, go back and check your work. So now that we have all of this beautiful data, I want you to plot some graphs. We need to plot the total revenue curve, average revenue curve, and marginal revenue curve, having the y-axis as revenue / price and the x-axis as quantity. Pause now and have a go. Alright, we should not have had too much trouble with this. The total revenue curve will be upward sloping, as you can see. And the average and marginal revenue curves will fall on top of each other at the price of $10. Super easy stuff. Now we'll look at a firm that has some price control. You'll notice that as I supply more, as the quantity increases, the price falls. This shouldn't be too surprising, as we've learned about economies of scale, and also, the less scarcity of a good, the lower the price you can charge. Again, we need to fill out this table, so calculate away and work out the total, marginal, and average revenue at each price and output level. Now, that was a little bit harder than before, but I'm sure you still got there. Check to see that you're correct. This time, due to the scale, let's draw them on two separate graphs. Total revenue on a graph with revenue up to 100 on the y-axis, and the MR and AR curves on a graph with revenue up to 16. It's just so that we can clearly show what's happening. So pause now and do that. Okay, here's the total revenue curve when the firm has some price control. It starts out looking like before, with that incline. But the total revenue grows slower and slower until it stops growing when quantity hits 7, and even falls as quantity goes from 8 to 9. The marginal and average revenue curves diverge in this example. Marginal revenue even goes negative. We can see that when marginal revenue equals 0, at 8, this is also the peak of the total revenue curve. We also know that total revenue will never get down to 0, as of course this is impossible when we're producing. Something you may not have noticed is that average revenue is equal to the price. It's also the demand curve, but we'll get into that later. We know that average revenue is equal to price because total revenue equals price times quantity, and we also know that average revenue is total revenue divided by quantity. Some simple substitution, and we see that AR equals P, average revenue equals price. Now moving on to profits. We all know that profit equals revenue minus costs, right? Well, kind of. That's what we call accounting profit. Revenue minus all explicit costs. Economic profit, however, is total revenue minus all explicit and implicit costs. That is, total revenue minus economic costs. Let's work through an example. let's say I get fired from teaching for stealing students' money. I decide then to go into business producing baseball bats. In my first year, I make a revenue of $1 million. Let's see what my accounting profit would be. I take off the cost of the wood that I used, the water, electricity, gas, insurance, the wages of the workers I had to pay, the cost of the machinery, and the 40 grand that I pay in loan interest. So I had to take out a loan to go into business here. This leaves me with a profit of $140,000, which seems pretty good. Then looking at economic profit, of course, I take into account the explicit accounting costs. But then we look at the opportunity cost as well. I could have earned 70 grand doing something else, despite not being able to teach anymore. I can still earn 70 grand. I'm pretty skilled. And then there's also the fact that I poured my life savings into the business. I could have earned 30 grand in interest just having the money sitting in a bank. Plus, I took a huge risk, so I really need to apply a premium to that. If this business venture went bad, it could have ruined me. This leaves me with an economic profit of $20,000, which doesn't sound that good, but what it means is I'm $20,000 better off than with my next best alternative. But what if? Let's change the scenarios a bit. What if I'm more skilled than even I thought? What if I could actually earn 90 grand instead of 70 in outside employment? My economic profit would then be zero. But normal profits are still being made. Normal profits are just enough to keep me in business. It covers all my explicit and implicit costs, but I make no economic profit. As my opportunity costs are covered, I'm not better off doing anything else, so I will stay in business. And yeah, that seems weird. But with zero economic profit, firms will stay in business. Now, what if my foregone wages were 95 grand? I could have earned 95 grand elsewhere, not being in business. I would make a negative economic profit. And as a rational person, I should leave the market. Now, it's important to note here that when we talk profits in this course, we're talking economic profits, sometimes called supernormal profits because they are higher than normal profits. Okay, make sure you understand all this and we will go through it a bit more in class.